Hello friends, so now this is shear force and bending moment diagram for cantilever beam. So this is simply part 2.2. In this, the case 3 is like cantilever of length L carrying uniformly distributed load of small w per unit run over the whole length. So simply this is a cantilever beam which is having a UDL throughout the length, and in this 2 points A and B, and the length of cantilever beam is L. So first we will make the reference for SFT and BMD. After then, in this case, we will move from free end to fixed end, or we can say simply point B to point A. So in this is the shear force equation. So this is simply plus Wx. Okay, so as per the sign convention, this is positive shear force, and this is Wx. The value of shear force is Wx. So simply because of the loading diagram, as you can see, this is the section for the loading diagram. In this is small w and this is x. So area of this rectangle, we can say simply Wx. So this is equal to shear force. And in this, after putting the value of x is equal to 0, the value of shear force at point B here, as x is equal to 0, so SB will be equal to 0, 0. And second, at x is equal to L at this point, and x is equal to L, then the value of SA will be equal to plus WL. So simply I can say SA will be equal to plus WL. Okay, so simply put the values. After then, this is WL, that is at point A, and next is the bending moment. And again, in this we'll move from free to fixed end. So here this mx is equal to minus wx squared by 2. So this is the equation. So minus because of the sign conversion, or we can say simply the hogging will be there. So this is negative, and the value of bending moment, that is wx squared by 2. So this is because this is a rectangle, the section of the beam, and in this the total load act on the centroid will be equal to Wx, simply Wx, will be act on like this, x by 2. So this is the force and this is perpendicular distance. So after multiplying the force into perpendicular distance, we will get moment. So simply moment will be equal to Wx squared by 2. So I have put here Wx squared by 2. After putting the value of x, first x is equal to 0, so I can say simply here x is equal to 0, then mb will be equal to 0. Okay, and at x is equal to here, at x is equal to L, so ma will be equal to minus w L square by 2. So we can just get value WL square by 2, and after putting the value, I just got the maximum bending moment in this case will be equal to WL square by 2. Okay, so this is maximum shear force, this is maximum bending moment. So this is case 3. Now next, case 4. In this we have a cantilever beam of length L and uniformly distributed load, simply UDL, whole length. So throughout the length, again throughout the length, and in this concentrated load W at the free end. Here if you want to check the unit, then the unit of this small w will be equal to Newton per meter, and this W is simply Newton. Okay, because this is depend on the length small w. So in this, first we'll make the reference for SFT and BMD. After then, again in this we will move from free end to fixed end. So here from B to and A, we will transfer. We'll move from free end B to fixed end L. So the value of shear force is like this. So simply this Wx is equal because of this UDL, and this capital W because of this point load. Okay, so simply this is W, so point load, and this is UDL. So as in last case 3, we have already discussed how this Wx is shear force. So summation of the both, and at x is equal to 0, the value of here at x is equal to 0, the value of shear force at point B will be equal to capital W, because of there is shear force 0 because of the UDL. So only point load will be considered here, and this is W. At x is equal to L. So at x is equal to L, the value of shear force will be equal to WL plus W. So this is the maximum shear force because of the both this UDL and point load. So WL plus W. Now next, this is a bending moment. Again, in this case, we will move from free end to fixed end, from B to A. In this, the equation is like Wx square by 2 plus Wx. So this first equation because of the UDL, and the second equation because of the simply point load. Here this is Wx square by 2 because of this UDL, and Wx because of point load. So after putting the value at x is equal to 0, we'll get moment at bending moment at point B is equal to 0, and at x is equal to L, we'll get the bending moment is equal to minus WL square by 2. So simply after putting the value, we'll get this is maximum bending moment. Now next case, in this case, as you can see, we have a cantilever beam of length L and having a uniformly distributed load small w, so UDL again, and a concentrated load but at point C, and this point C is at a distance of A from the free end. Okay, so first we'll make a reference for SFT BMD. After then again in this case, now just remember this, as the load is at point C, so we have now two sections. This is section 1, that is B to C, and section 2, that is C2A. So we'll solve section by section. So first we'll consider section B to C. So in this section B to C only we have a UDL. So we'll take a shear force like this as x is equal to Wx, and after putting the value x is equal to 0, so here x is equal to 0, so we have SB is equal to 0, and second at x is equal to A, so here at point C when x is equal to A, so we have a SC, means shear force at point C is equal to WA. You can say simply this is WA. Okay, and now next section, that is C2A section number 2. So in this the shear force will be equal to Wx plus capital W. Okay, in this again we will put the value of x is equal to A, so we'll get the value of WA plus W. Okay, so just here it will go upward side. Okay, like this. So now this total at point C, this is WA plus capital W. Okay, and after then again moving from C to A, then at x is equal to L, this value is WL plus W. So like this. So this is the maximum shear force, that is small WL plus capital W in this case. Next is bending moment, and for bending moment we will first take the section B to C. So in this B to C, this mx is equal to minus W x square by 2, and after putting the value of x is equal to 0 and b is equal to 0 and x is equal to A, this. So just mention here. Okay, so this is equal to WA square by 2. Next is for section C2A, from C to A. So in this we have the equation like this, Wx square by 2 plus Wx minus A. So because of the UDL, this is simply Wx square by 2, this is okay, but this is because of the point load. As you can see, we are considering section from this point like this. Okay, now for C2A you have to take a section like this is XX and the distance of this is like X. So what about this length? So this length will be equal to X minus A. Okay, because this is total, here to here this is X and this is A. So we'll just subtracting this length A, then this is X minus A. So this is the force and this is perpendicular distance X minus A. So I have put here because of the point load, So after putting the value at x is equal to A, the value is same, and at x is equal to L, the value is this. So this one is the maximum value. So okay, so this is the maximum bending moment of the beam. So next case, this is case number 6. So in this a simple cantilever beam which is having length L and at point C. Okay, till point C we have only this UDL. Okay, and okay, now this is simple, the shear force and bending moment reference, and in this we will move from, so first we will move from this B to C. This is section number 1 and this is section number 1 and this is section number 2. So first we will calculate for section number 1. So in this, as you can see, shear force will be equal to Wx. Okay, and after putting the value we'll get x equal to 0, SB is equal to 0, and at x is equal to A, SC will be equal to WA. Okay, no problem. So we have this value and value of this is equal to WA. After then from C to A, as there is no load, this is no load shown. Okay, in this section there is no load, so simply this WA will be continued throughout the length. Okay, so now next, this is equation is like this. So simply WA and WA will be continued throughout the length because there is no load between C to A. So simply this will be the maximum shear force. Okay, and second, for bending moment diagram, so simply here, as you can see, for section B to C, for section 1 B to C, we have Wx square by 2. Okay, so after putting the value we will get like this. So just we have here 0 bending moment, and here we have the bending moment value is minus WA square by 2. Okay, now next from section C to A, as there is no load, but the effect of this UDL will be act on C2a. Yes, like here in shear force, you can see this is constant, but at here, as the distance is increasing, then the force into perpendicular distance also increasing. So moment will be increased, but the moment will be taken like, as you can see, I have taken like WA into X minus A. So how? So first we will just make a concentrated load, point load. We just convert this UDL into a point load, then simply this point load will be equal to small w into A. Okay, so this is point load, and now if I'm taking a section here, okay, this is XX for section C2A, then this will be equal to, so what about this length? Okay, so this length will be equal to, first this is A by 2. Okay, this will be a by 2, like this from here. Yeah, this will be A by 2. This length will be simply X minus A by 2. Okay, because this is total X here. Yeah, total X. So, and this is W A by 2. So simply X minus A by 2, and this is load is WA. So simply force, that is WA, and distance is X minus A by 2. Simply force into perpendicular distance. So that is a bending moment. Here, just put the value of X is equal to L, and you will get the value of this. So simply this is a straight line, and this maximum bending moment is equal to WAL minus A by 2. So this is the maximum shear force in this case, and the maximum bending moment.